Hello friends, how are you? Today I am going to talk about matrices. I am going to give the introduction, what exactly the matrices are, and I am going to talk about the different types of matrices. Friends, matrices is an important branch of mathematics. By use of matrices, we can carry out research, scientific studies, research analysis, and we can solve the complicated equations in quite easy way. And by using the matrices, we can frame the 2 variable, 3 variable and 4 variable equation into very simple form, and we can find out unknown variables. In this video, I am going to talk about what are the different types of matrices. In next video, I shall be talking about the various topics like operation, multiplication, addition, etc. in the second video. So in this video, I am just going to talk about the different types of matrices. The different types of matrices are row matrix, column matrix, zero matrix, also called as a null matrix, rectangular matrix, square matrix, negative matrix, diagonal matrix, scalar matrix, unit matrix, upper triangular matrix, lower triangular matrix, symmetric matrix, skew symmetric matrix, singular matrix, and non-singular matrix. These are the few various types of matrices. Now we'll define one by one and understand what exactly the meaning of these matrices. Suppose we have 2 variable equation like 2x plus 3y equals to 5 and 6x plus 8y equals to 9. These are the 2 equations of 2 variables. X is the first variable, y is the second variable. So these equations, if you wish to solve, you can solve by the regular method like subtraction and addition, and another method is a matrix method. So these numbers, the coefficients of these variables can be arranged in the form of row and column like 2 and 3, 6 and 8. So here is a xy equals to 5 and 9. That means the given equations can be arranged in a row and column form. So arrangement of numbers in row and column form is called matrix. In a matrix, there are the horizontal like A, B, C, D, etc. It is a horizontal row, and A, 1, 2, this is column. B, 4, 5, this is the second column. 1, 8, third column. C, 1, 8 is the third column. D, 0, 0 is the fourth column. So it is a column. It is the first column. This is the second column. This is the third column, and it is a fourth column. So matrix having columns and also having the rows. So like this is the first row, this is the second row, it is the third row. So the arrangement of rows and columns is nothing but called as a matrix. So now understand one by one what are the different types of matrices. First one is a row matrix. The row matrix nothing but having only one row. Example, this is a matrix having 3 elements and it is having one row. It is a one row. Only single row is there. Therefore, it is called as a row matrix. Example 2, A, B, C, D. There are the 4 elements in the row. So it is as well as a row matrix. And when you talk about the A, B, C, it is a single row, but A is the first column, B under the second column, and C is under the third column. That means it is having 3 columns. It is having one row. It is having one row and 3 columns. It can be written as A, B, C. At the end of the matrix, at the end of the bracket, we write here 1, cross 3. We read it as a 1 by 3 matrix. So 1 row and the 3 column, therefore it is a 1 by 3. It is called as a 3. 1 by 3. So this cross symbol is called by. So 1 by 3 matrix. So a row matrix is having one row only. Thus, a matrix having only one row is called row matrix. Now, second one is a column matrix. Column means having only column. There are so A, B, C having a single column. A, B, C, D, single column. A, B, C, D, E, F, any number of elements but single column. So when a matrix having only one column, then it is called as a column matrix. So it is a column matrix. A, B, C is a column matrix. And here are the only one column, but this is the first row, R1. This is the second row, R2. This is the third row, R3. But there is only one column, therefore it is a C1. That means it is having 3 rows and 1 column. So it can be denoted as A, B, C is there. It can be denoted as 3 by 1 matrix because having 3 rows and single column. So whenever the matrix having only one column, then it is called as a column matrix. So a matrix having single column is called column matrix. Now, third type is the zero matrix. Consider a matrix A equals to 0, 0, 0, 0. In this matrix, all elements are 0. So, whenever all elements of a matrix are 0, it is called as a zero matrix, or it is also called as a null matrix. Let us take one more example. B equals to 0, 0, 0, 0, 0, 0, 0. All elements are 0. And the matrix A 0, 0, 0, 0. There are the 2 rows and 2 columns. Therefore, it is a 2 by 2. And matrix B having 3 rows and 3 columns. Therefore, 3 by 3. So B is a zero matrix of 3 by 3 type. A is a zero matrix of 2 by 2. So what is a zero matrix? Zero matrix. If all elements of a matrix are 0, then it is called zero matrix. Now, fourth one is a rectangular matrix. Rectangular matrix nothing but number of rows not equal to number of columns. Then it is called a rectangular matrix. Example, suppose matrix A, B, C, D, E, F. It is, if you join all the parts starting from first to the last, you will be getting a rectangle. That is, if I start joining the elements starting from A, if I join all the elements without lifting the pen, coming back to the same element, we get a shape of rectangle. When we get the shape of rectangle, it is called a rectangular matrix. One more example, suppose B equals to A, B, C, D, E, F. even it is a rectangular matrix, because number of rows not equal to number of columns. In matrix A, there are the two rows and 3 columns. So the number of rows not equal to number of columns. Therefore, matrix A is a rectangular matrix. Similarly, in matrix B, the rows, there are the 3 rows and 2 columns. So number of rows not equal to number of columns. So even the matrix B is a rectangular matrix. Matrix A, what type of matrix? It is 2 by 3 type of matrix. And matrix B is a 3 by 2. So matrix A 2 by 3 and matrix B 3 by 2. So how to define rectangular matrix? If in a matrix number of rows and columns and number of columns are different, then it is called rectangular matrix. In coming episode of matrices, even we will be proving a rectangular matrix cannot have adjoint and cannot have the inverse. So a rectangular matrix have no inverse and cannot have the adjoint as well as. So that we will be learning in the coming episodes. After 3-4 episodes, I shall be talking about a rectangular matrix cannot have inverse as well as cannot have the adjoint matrix. Fifth one is square matrix. Number of rows equal to number of columns. If in a matrix, if number of rows are equal to number of columns, then it is called square matrix. Example, A equals to A, B, C, D. So number of rows and number of columns are equal. It is a 2 by 2 matrix. So it is a square matrix. Similarly, consider one more example, A, B, C, E, F, G, H, I, J. So in this matrix, the number of rows 3, number of columns also 3. So it is a 3 by 3 matrix. So both matrix A and B are nothing but what type of matrices? They are square matrices. So how to define the square matrix? If in a matrix if number of rows equals to number of columns, then it is called square matrix. When you got the two square matrices, they can be added, they can be subtracted, and they can be multiplied. In coming videos, I shall be talking about how to add, subtract, and multiply two square matrices. Even I shall be talking about how to find out determinant of a given square matrix. So if you have not subscribed the channel, please subscribe it so that you will be get benefited. You will be able to learn how to find out determinant and addition, subtraction, and multiplication of square matrices. Now let us move to the next one, that is the negative matrix. Suppose we are having a matrix A that is 2 by 3 type, whatever the type, 2 by 3 or 3 by 2 or whatever may be. But if you multiply the given matrix by -1, and each element will also get multiplied by -1, that is a minus A, minus B, minus into minus plus, -2, -3, -4. So if we multiply each element each element of a given matrix by -1, then resulting matrix is negative of A, negative of matrix A, that is the negative of original. Now next one is the diagonal matrix. Suppose I got a matrix here A, B, C, D, E, F, G, H, I. Now when I got a matrix here, of course it is a square matrix. So the elements of the diagonal, the elements, these are the A, E, I. This is nothing but diagonal of the given matrix. If we make this B0, C0, D0, H0 and G0, then what do you get here? A equals to A 0 0 0 E, this is even 0 0 E 0 0 0 I. What do you observe? What do you observe? The elements along the diagonal not 0, but remaining elements are 0 in the matrix A. That means the elements along the diagonal not 0, rest of the elements are 0. Only the elements along the diagonal not equal to 0. So a square matrix, in which the elements along diagonal not equal to 0, but rest of elements equals to 0, called diagonal matrix. Now next one is the scalar matrix. Scalar matrix is also like diagonal matrix only. For example, A equals to here is 0 0 0 0 0 and 0, but along the diagonal, instead of in case of diagonal matrix we have seen the elements were not, there was no condition whether they are equal or not equal, but in case of the scalar matrix all the elements along the diagonal have to be equal, they must be equal. So when the elements, in case of diagonal matrix, if all the elements along the diagonals are equal and rest of the elements are 0, then it is called as a scalar matrix. Let us take one more example. Suppose here 5 0 0 0 5 0 0 0 5. So the elements along the diagonal are equal and the rest of the elements are 0. So such type of matrix is nothing but called scalar matrix. So definition of scalar matrix: if in a square matrix, if all elements along diagonal are equal and rest of elements equals to 0, then it is called Scalar matrix. A unit matrix is one in which the value of diagonal element equal to 1 and remaining numbers are 0, like 1 0 0 0 1 0 0 0 1. Then it is called unit matrix, and unit matrix has to be a square matrix. So definition of unit matrix: a square matrix, in which all diagonal elements equals to unity and remaining elements are 0. Then it is called unit matrix. Next one, upper triangular matrix. A matrix in which all elements below diagonal are 0. So what is a diagonal? This is a diagonal, and below diagonal there are the 0 0 0. And upper triangular, that means upper above the diagonal, if you trace all the elements, it will become a triangle. Therefore it is called upper triangular matrix. And below the diagonal, all the elements are 0. One more example, in matrix B, if you start tracing, if you trace all the elements from diagonal here and here, you will receive, it will get a triangle. And below this triangle, all the elements are 0. Such type of matrix nothing but called upper triangular matrix. The next one, lower triangular matrix. A square matrix in which all elements above diagonal are 0. This is a diagonal, and above diagonal all the elements are 0. And if you trace them, all the elements, here you will get a triangle, and the triangle is, the elements are present below the diagonal, along the diagonal and below diagonal, but above the diagonal all the elements are 0. In second example, A4D, this is a diagonal, and above the diagonal all the elements are 0. Therefore a square matrix in which all elements above diagonal are 0 is nothing but called lower triangular matrix. Friends, before understanding what is symmetric matrix, let us understand the following logic. Now ABC are the elements belonging to the first row, therefore write 1 1 1, and DEF belongs to the second row, therefore 2 2 and 2 written as a suffix. Similarly, GHI belongs to third row, therefore 3 3 and 3. After that, ADG belongs to the first column, therefore one more addition, that is A11, D21 and G31. Similarly, BEH belongs to second column, so we add 2 2 and 2 over there, and CFI belongs to the third column, therefore 3 3 3. Now for example, let us consider a matrix A11, A12, A13, A21, A22, A23, A31, A32 and A33. Suppose this is equivalent to 4 1 5 2 1 0 3 8 9. Now suppose I want to find out what is the value of A11. A11 nothing but 4, where the first element belongs to the row and the second number belongs to column. So A11, so row value equals to 1 and column value equals to 1. Suppose A23 equals to 0, here the row value 2 and the column value 3. So the A23 corresponding value of A23 element equals to 0. Similarly, one more example, A31 equals to 3. That means corresponding value of the row equals to 3 and column value equals to 1. In generally, we can write Aij. Aij, I nothing but row number, and j is nothing but column number. So column number. On the basis of this idea, we can now understand what exactly the symmetric matrix is. Now we frame a matrix. To make you understand, I am giving one example. Suppose I am having A11 equals to 5. Here I have written 5 here. Now A12 equals to 7. So I have written the 7 here. Then what is the reverse of 1 2? Reverse of 1 2 is 2 1. That is the A21. A21 also 7. So A21 will come here. So A12, A21 are same. Now let us see A13. A13 is equal to suppose 10. What is the reverse of 1 3? Reverse of 1 3 is a 3 1. So A31 is also 10. So here I write 10 here and 3 1 also 10. After that A22, any element whatever you want, suppose 6, no problem. Now A23, A23 suppose 20. A23 equals to 20. So I have written 20 here. Then and what is the reverse of 2 3? That is a 3 2. So A32 also 20. Where is the 3 2? 3 2 is here. And whatever you wish to write here can be the any element. So a matrix in which the value of A12 equals to A21 and A31 value equals to A13 and A23 value equals to A32. Such type of matrix is called symmetric matrix. Now let us define what exactly the definition of symmetric matrix is. Now we define symmetric matrix as, suppose a square matrix. A square matrix A equals to Aij is called symmetric matrix if Aij, the value of Aij equals to value of Aj if I not equal to j. This is the definition of symmetric matrix. Now next one is skew symmetric matrix. A square matrix Aij is said to be skew symmetric matrix if Aij is equals to minus of Aj. For example, I am having A12. The value of A12 equals to minus 2 and the value of A21 equals to 2. Implies A12 is nothing but negative of A21. So the condition of skew symmetric matrix is satisfied here. Now let us check for other one like A13 equals to 4 and A31 equals to minus 4. Even here the condition of A13 is equals to minus of A31. Even the condition of skew symmetric matrix is also satisfied here. And the third one is left one, the 2 3, a 2 3, a 2 3 equals to minus 3 and a 3 2 equals to 3. Here even the condition of a 2 3 equals to minus of a 3 2. Here the condition of skew symmetric matrix is satisfied here. Therefore, given matrix is the skew symmetric matrix. Next one is the singular matrix. If the determinant of a matrix is 0, then it is called singular matrix. Example, we got a matrix A 16 8 4 2 whose determinant is equals to 0. Determinant of this matrix equals to 0, then it is a singular matrix. How? Now the last one is the non-singular matrix. That is a non-singular matrix. If determinant of the matrix not 0, then it is called non-singular matrix. Example, suppose A equals to 1 5 9 2. The determinant of this matrix nothing but 2 minus 45, that is equals to minus 43. The determinant of this matrix not equal to 0, hence this matrix is a non-singular matrix. This is non-singular matrix and it is a singular. So friends, these are the various types of matrices. In next video, I shall be trying to do the problems on addition and subtraction of matrices. So keep on watching. Wish you good luck. Meet you again with another video. Don't forget to share it with your friends so that more and more friends of you will get benefited. Wish you good luck. All the best.